This keychain device is called an iTAG. You can pick it up on Amazon for just a few dollars. And what it is a small keychain type device that puts a Bluetooth signal onto your smartphone. And if this device and whatever it's clicked onto leaves the proximity of your smartphone, it sends you an alert that says you may want to go look for it. I want to make a few measurements on this device, and I'm going to be using some Keithley and Tektronix instrumentation to do that. So what we have is a Keithley 2230 power supply. We have it set to 1.5 volts because this device runs off of a button cell battery, and we're using that for power. Monitoring the current on the iTAG keychain is a DMM7510. And I want you to take a look at two things. You can see some small pulses that are being displayed on the screen. That's actually the pulses that I think are being generated as the iTAG device pings the cell phone for a Bluetooth signal, and actually the current draw is being increased when that ping takes place. We're going to take a look at that, see if that's true. And we're going to do that by using the Tektronix RSA306 spectrum analyzer running SignalVU-PC. So we have a couple of screens displayed on SignalVU, traditional spectrum analyzer display, and really I would expect to see a Bluetooth signal coming from the iTAG device, and I really can't see that. Every now and then I will see a spike at the center frequency, which is about 2.426 gigahertz, but a traditional spectrum analyzer just doesn't see that the way we want. But that's okay, because the RSA306 is a real-time spectrum analyzer, and it can heat grade signals and let you see transients up to 100 microseconds guaranteed point of intercept. So it's really easy now to see this Bluetooth signal that's being generated by the iTAG right here in the center frequency. You can see some other interference going on from time to time as we're showing the screen. So what I'm going to do is I'm going to stop this instrument from measuring, and I'm going to throw up two markers. One marker I'm going to put right here on one of the power points that are shown in the spectrogram, and I'm going to move the other marker to another power point in the spectrogram. And we can see the delta between those two markers is about 106 microseconds. We could zoom in and get a better reading, but it's about 100 microseconds. And we're going to go over to the 7510 DMM, and we're going to take a look at those pulses. And if our assumption is correct, that that is Bluetooth that's causing that extra current draw, they should correlate with what's on the RSA306. Now you'll see the dotted line. That's actually a triggering function, and this instrument can trigger on current. And right now I have it set to trigger on 700 milliamps of current. I'm going to push the button on the iTAG device so it will try to sync up with a phone, and it's going to draw more current. It'll actually trigger the instrument. There we go. We just triggered the instrument, and we're going to throw up two cursors to take a look at the difference between these two current pulses. So we have a cursor So we have the cursors pretty close to the two current pulses. I'm doing this with one hand, so it's a little bit difficult. And you can see, sure enough, it's about 100 microseconds delta between those two cursors. And that actually correlates with the RSA306. So we do know that those are Bluetooth pulses that are going by. I can also zoom in on this particular signal, which was when I pushed the iTAG button to send out the sync pulse. You can see it took out more current to do that. And we can see that the current was actually ringing. And it was ringing with the same frequency that the beep was getting put out. Again, I can move the cursors to display the delta time between those two. If I take the inverse of that, I'll get the frequency that that beep went off at. Again, the frequency would match the current draw as it changes. So that's just a way to do a quick analysis of this keychain device, verifying its current draw over time, and also taking a look at its signal with the RSA 306 real-time spectrum analyzer.